This is an audio tutorial or video tutorial for those of you who want a little bit of assistance with prepping the pGLO lab for the first time. So when you get ready to start, you've got your book with the instructions that come with the pGLO set. The main things that you'll have in the box, you'll have your agar packet that you can make your agar, which is one of the first things you need to do. The packet that has the other reagents and the bacteria and the plasmid and so forth, a whole bunch of sterile DPTPs, disposable plastic transfer pipettes. You've also got sterile loops and several sleeves of the small petri dishes and so forth. So to get started to make your agar, the first thing you're going to need is you're going to need a 1,000 milliliter beaker and 500 milliliters of distilled water. All the instructions are in the book. I always get the Think investigation kit because it has the inquiry extension, but you don't have to do that. You can just do the straight pGLO lab without the extensions. So we're just going to talk about prepping the pGLO lab itself. So in the book it tells you about making the agar. If you have never made agar before, you need 500 milliliters distilled water in a 1 liter flask, and then you're going to need to add the powder to that and heat and stir it. Okay, you can put it on a stir plate like this one here, and you can see that I've set it to stir so that you can see the it's not the video's not working very well. Anyway, you can see the powder being dissolved in the water. I like to heat it a little bit while it's stirring because that helps it dissolve more easily. It takes a little while for it to dissolve, so you'll need to keep it going for a while. You've got, over time it'll get a little bit more clear, but probably won't be totally clear until after you put it in the microwave. Once you get all the powder dissolved, then you can put it in the microwave and heat it to boiling and swirl it several times. The important thing to remember is that it's going to be very, very hot. You have to watch it constantly. Depending on how hot you got it when you were heating it on the plate, it may take up to a minute and a half or 2 minutes for it to boil the first time. If you got it pretty hot before that point, then it may boil more quickly. So be sure and watch it carefully. When it starts to boil, then you need to stop the microwave and use a hand protector because it's going to be very hot to swirl the flask a little bit. You can see as you heat it, you'll need to do this at least 3 times. Heat it to boiling, swirl it to dissolve or mix up more of the powder. And finally, when it becomes really clear like this, that's when it's ready to go. You need to heat it. Heat and boil and cool it at least 3 times and make sure that it gets sterile. Sorry about the quality of the video. But boiling it, stirring it, boiling it, and swirling it at least 3 times to make sure that it's sterile until it's really clear like this, and you can tell that all the powder has been dissolved. Once you're ready to it has to cool down to about 50 degrees. In other words, you need to get the flask to the point where you can hold it carefully, hold it in your hand without any hand protection, so that it's the right temperature to pour. While you're waiting for that, you can go ahead and prepare your ampicillin and your arabinose that will need to be added to the agar step by step as you're pouring your plate. So here's the arabinose lyophilized and the ampicillin lyophilized, and you'll also use the transformation solution that comes with the kit to rehydrate that. So you'll use a sterile pipette. It takes, I believe it says 3 milliliters of the transformation solution and the arabinose. The arabinose is the one that takes the longest to dissolve. It takes a good while for it to dissolve. So you put your liquid in there, and then you're just going to need to shake it. And you can see that the powder is pretty thick there at the bottom. It takes at least 10 minutes, if not longer. If you have time, you can continue to shake it. If you have access to a vibrator you can get it, you put it on that to get it, but eventually it will become clear and everything's dissolved like it shows here. Also, make sure before you start pouring your plates that you clean your table carefully. There are many substances that you can use, some kind of disinfectant. Clorox wipes work really well. You can also use isopropyl alcohol or something like that, just something that's going to clean it. You need to do that before and after using the bacteria anyway, and so get used to doing that as you're preparing it. So as you prepare your arabinose and your ampicillin, in the ampicillin you're going to use 3 milliliters of the transformation solution. It dissolves pretty quickly, and then you'll also use 3 milliliters of transformation solution in the arabinose. The only reason you're using the transformation solution here is that it needs to be some kind of sterile liquid, and it's just a convenient. They send you a pretty decent size bottle of it, or little bottle of it. It's already sterile, but you could also use sterile water with it if for some reason you need to have don't have your transformation solution. And so you'll add those together so that it mixes. Also, make sure that you have labeled your plates. This particular one shows that it's going to have LB agar, the Lurie broth agar. You'll have 16 plates that are LB. You'll have 16 that are LB plus the ampicillin, and then you'll have 8 that are LB plus the LB and amp plus the arabinose for the process. So you can get all of that ready while you're waiting for the agar to cool to the point where you can handle the flask. So 16 LB plates, and then you'll add the ampicillin to the agar that is left, and then you'll have 16 LB plates with ampicillin in them, and after you pour those 16 plates, then you can add the arabinose to the rest, and that'll be enough for 8 more plates. If you have a little bit of extra, just try to have some extra sterile plates handy, and you can pour those. It never hurts to have a few extra plates here and there. Sometimes the LB plates, especially as they're curing on the countertop, may get a little bit of contamination from yeast or something like that may be in the air, and so you may lose 1 or 2 of them along the way. So this is just repeating the directions about heating the agar there. Here are my plates laid out. This time I've got 16 plates laid out. You want to make sure that your plates are with the lid up this time, because you're going to lift the lid and pour the agar in. The instructions tell you to stack them four in a row, in a stack, and pour the bottom plate and then the next plate and the next plate. I find that a little bit complicated to do. Since I don't pour plates all the time, and especially not these small ones, I have a tendency to make a little bit more of a mess when I do that. So I would rather lay them out individually, and then I can pour them one at a time. It makes it a little bit easier for me. So here's the video showing you the basic process of pouring the plates. I like to put, I'm talking to my lab aide. I had a student lab aide helping me that day, and so I was showing her how to pour plates. I like to put a little paper towel around the edge to catch a drip. Because it just keeps it from being quite as messy. I do have a tendency to spill some. You can see there's some there on the table that I had let Danielle pour because I was teaching her how to pour plates. But you just basically pour a little bit in there, put the lid back on. You don't want to leave the lid off of the plate very long, just long enough to pour your agar and then put it back on. If you need to stop every now and then, put your hand down or whatever, put the plastic down, the flask down, then feel free to do that. It's not a problem. So here's, I've poured the first set of plates. I put the ampicillin in the agar and swirled it around, and then I poured the ampicillin plates, and then this is the stage where I'm adding the arabinose. And so you just basically pour the liquid into the flask, and then you just pick up the flask and swirl it around, and then you're ready to pour the next set of plates. So once you've got all your plates poured, they have to sit there and cool. You want them to sit there and cool until the agar solidifies, and then you can stack them up and move them over in another area out of the way. The instructions usually say to let them cure at room temperature for a day or so. And once they're solidified enough, you can turn them over so that the condensation will be on the lid will be underneath the agar instead of on top of it, so that it doesn't drip down onto the surface of the agar. So once that's done, the next day or so, then you're going to be ready to start preparing your starter plates. You will need to, first of all, so before you can make your starter plates, you're going to have to rehydrate the bacteria. They send you also a little bottle of nutrient broth that is sterile, and you're going to add 250 microliters of the sterile nutrient broth to the lyophilized E. coli and let that rate. You'll then want to put the E. coli into the incubator. If you have an incubator set for 37 Celsius, you'll want to put the E. coli into the incubator for somewhere 8 to 24 hours, and it says if you don't have an incubator, then leave it at room temperature for 16 to 24 hours to give the bacteria a chance to start growing. And because you want to, when you streak them, you want the bacteria to be actively growing. So here's my nutrient broth and the E. coli, the lyophilized E. coli. So we're just going to add the broth to the E. coli and let it rehydrate, and then you'll be ready to put it into the incubator. Again, set your incubator to 37 degrees, as close as you can get to that. Sometimes they cycle on and off and get a little bit cooler, a little bit warm, depending on how your incubator is set up. Mine has wire shelves. I usually put this little bottle in a culture dish to set into the incubator just to keep it from tipping over. Anyway, let it heat, and then when you come back the next day or later that day, you can be ready to streak your plates. The first ones, so you're going to need 8 of your plain LB plates and a sterile loop. So you'll get out one of your packages of loops. Be sure to open it at the Ziploc end, tear off the tab there at the Ziploc end, rather than make the mistake that I did the first time with not looking and cut off the other end, and then you're having to take the loops out of the package by the loop end, which is making them not sterile anymore. So it shows you how to do this, and what you're going to do is you're going to strike the plates for individual colonies. If you haven't done this before, then you get a loop. You stick the loop into the bottle of E. coli. Make sure you've got some fluid on the loop. It's going to look sort of like a miniature bubble wand, and they're going to streak it back and forth on one side of the plate, keeping it close to the edge like it shows right here, and then turn the plate a quarter of a turn and streak across that a couple of times, and then through this area like this, and then you want to do it again a couple of times, and then the last time you're going to have part of it just pull down really close. If you look at the pictures really carefully, it shows you basically how to do that. But you want to streak it so that you're going to have some individual colonies spread out, and that's the proper technique to do that. So I'm going to label these plates LB E. coli because they're going to have the E. coli streaked on them. And once you get them all streaked, make sure you clean your table before and after. I've tried to show here that it had a little liquid in there, but I don't think you can see it. You may or may not be able to see the surface of the auger where I have streaked on there, but once you get them all streaked, then you're going to put them again upside down into your incubator at 37 degrees Celsius and leave them overnight. They need to heat and allow to grow for somewhere between 16 and 24 hours, and then the next day you'll have something that looks like this. The students need to choose several of these small colonies to make their solution for the transformation experiment. And when you're preparing for the next thing, then you're going to need to aliquot some of the solutions for the students, and your kit will have plenty of tubes for you to aliquot things into. You'll need a transformation solution for each one. You'll need some LB broth for each group, and they'll have to have their plates, of course, that they'll need. Before your lab, you'll also need to rehydrate the plasmid with some transformation solution. Very simple to do. There's not a whole lot in there. It doesn't look like there's anything. You won't see a whole lot once you get it in there. It doesn't take very much because the student groups are going to get one loop full, or about 10 microliters of the plasmid solution for each lab group. This takes 250 microliters of the transformation solution, and again, we're using the transformation solution because it's a sterile solution that they send you. You could also use sterile water if you had that handy. So just take your solution, put it into your ampule there, and then put the lid back on. Shake it a little bit to make sure that it says invert it, to ensure that the DNA is dissolved. And then you want to make sure that you get all the liquid back down into the bottle. If you need to run it in a little microcentrifuge for a little bit, you can do that too. It should fit most of them. It takes at least 10 minutes for the plasma to rehydrate, so you can even do this just shortly before your lab starts. I label the tubes for them. I put TS for transformation solution, and you put about a milliliter in each one. The tubes have a little mark here on the side that marks 1 milliliter, and so if you're not trustful of your pipetting techniques, you can always look at the level that's marked there on the outside of the tubes. So each group will need a tube of transformation solution. They'll need a tube of nutrient broth, and so I just labeled that LB. And then if you're doing some of the other activities later on, you may need some other tubes as well. Each group will also need 4 plates. They need 1 plain LB plate, they need 2 LB ampicillin plates, and then 1 LB amp era plate. That they'll label according to the instructions in the lab manual, minus pGLO, minus pGLO, plus pGLO, plus pGLO. This will be their positive control showing that the E. coli can grow. This will be their negative control showing that the ampicillin prevents the untransformed bacteria from growing. This will show that the transformed bacteria will grow, and then this will allow them to glow under ultraviolet light. So I put together a lab kit for my students. It just makes everything simple to have everything there together. I go to Walmart and buy these plastic shoe boxes. I have a whole bunch of them that we use for various labs all the time. And so I put all these things that they are going to need into the lab kit. That way they can just grab their materials and go. So they'll need a package of the sterile DPTPs. They'll need a package of loops. One of the little green blocks or some other receptacle that you use as a test tube holder. I gave them a couple of these, and they'll need 2 empty tubes for their plus and minus pGLO solutions, and then their transformation solution in LB broth. I gave them an extra one just to use as a float or for a test tube holder for their needs there. They'll need their stack of plates. I just go ahead and give them the stack of plates and tape them together, and a stock plate with the LB, the E. coli that's grown up overnight that you streaked, the starter plates. A extra fine point Sharpie is a good thing to have there. They'll need something to write on their plates with. They need to put a group name on. They'll need to put their plus and minus pGLO, label their tubes plus and minus so they'll know which one's which, and make sure that they have everything labeled and ready to go. I also give them a styrofoam cup to put their ice in, because they'll need an ice bath, and this is just an easy way to give them enough. They don't need a whole lot per group. They just need a cup of ice to chill their tubes in. So I put all that together in the shoebox, and then I just stack those up on my lab cart, and they're ready to go when the students come to class. I always stop at Sonic on my way to school and buy a bag of ice. Sonic ice works really well if you don't have access to an ice maker that makes this kind of crunchy ice, not the ice cubes. This works better because it completely surrounds the tubes and can chill them, whereas cubes have a hard time conforming to the size and shape of the microcentrifuge tubes. And so the Sonic ice, you can get a 10-pound bag of it for about $3, which should be probably enough for all of your labs, even if you have labs every period of every day. And I just put it in the freezer, and then I just scoop out a little bit into an ice bucket to have in class for them to use for their lab. So here are the plates ready to go. These are the ones that have come out of the incubator, I think. And then the next day when we take them out after they do their transformation, this is the plates from one of my groups on the UV transilluminator showing their LB minus or pGLO plate that shows the growing E. coli, the LB amp pGLO minus that shows that there is no growth there, the LB amp plus pGLO that shows the transformed colonies, and then here's one that got a really good output from their transformation experiment, glowing under ultraviolet light. This is a fun lab to do. It's my favorite lab of the year. The kids love it. It is a little bit of work to do it, but it's really worthwhile. The time and the cost of it is very worthwhile. And if you haven't done this before, I encourage you to take the stab and just do it. It's great. Bye.